Good day, everyone. We are about to report compressive strength of concrete hollow blocks. The flow of our presentation will go as follows. We will discuss its definition, history, application, background information, existing standards, manufacturing process, and test for compressive strength. So to start this, what is a concrete hollow block? Concrete masonry units or CMU, also known as hollow concrete blocks, concrete bricks, or concrete masonry. Concrete blocks are composed of Portland cement and aggregate. The high-density blocks may use sand and gravel, while low-density blocks use industrial waste instead of aggregate. Lightweight blocks are made using aerated concrete. The hollow concrete blocks are manufactured, hardened, and cured before reaching the site and is a very durable and strong material. History of concrete hollow blocks. Concrete mortar was used by the Romans as early as 200 BC to bind shaped stones together in the constructions of buildings. During the reign of the Roman Emperor Caligula in 37 to 41 AD, small blocks of precast concrete were used as a construction material in the region around present-day Naples, Italy. Much of a concrete technology developed by the Romans was lost after the fall of the Roman Empire in the 5th century. It was not until 1824 that the English stonemason Joseph Aspdin developed Portland cement, which became one of the key components of modern concrete. The first hollow concrete block was designed in 1890 by Harmon S. Palmer in the United States. After 10 years of experimenting, Palmer patented the design in 1900s. Palmer's blocks were in 8 inches or 20.3 centimeters by 10 inches by 30 inches, and they were so heavy that they had to be lifted into place with a small crane. By 1985, an estimated of 1,500 companies were manufacturing concrete blocks in the United States alone.
So after knowing the definition and the history of concrete hollow blocks, we will now proceed to the application and background of it. So first of all is the applications of concrete hollow blocks. Next, the concrete hollow blocks can be used for exterior load-bearing walls, interior walls, panel walls, columns, retaining walls, and compound walls. So, sa exterior load-bearing walls, yung mga exterior load-bearing walls is a wall that bears a load resting upon it by conducting its weight to a foundation structure. Pagdating naman sa interior walls, katulad lang din siya ng exterior load-bearing walls, pero pag sinabing interior walls, from the word itself, interior, nasa loob siya ng mismong structure. Next is yung panel walls. The wall panel is a single piece of material which is visible siya and exposed siya sa covering ng isang wall. Next naman is yung column. Dahil yung column is made up of concrete, minsan ginagamitan din natin siya ng CHBs. Next is yung retaining walls. The retaining walls are structures designed to restrain soil to a slope that it will not naturally keep to. So, basically, itong retaining walls is ginagamit sa mga, of course, sa mga slopey area, and madalas, ginagamit din ang CHBs para makapag-construct ng mga retaining walls. And, sunod naman is yung compound walls. A compound wall is a wall separating two independent plot. So, sa compound walls naman, parang binibuild siya from the two neighborhood jointly. Bale, sa dalawang bahay na magkadikit, madalas natin makikita yung mga compound walls. Dahil nga magkadikit lang sila, minsan ang ginagamit na lang nila is isang wall, pero may mga gumagamit pa naman ng magkahiwalay na walls. Next, it can also be used for the in demand not only for household constructions but department or agencies engaged in construction including PWD, housing boards, and urban development corporations, road transport corporations, and forest departments use hollow blocks because of cost effectiveness. Dahil nga cost efficient itong CHBs, hindi lang sa mga residential structures ginagamit itong CHBs. Na-adapt na rin siya ng mga commercial buildings like departments or agencies na ginagamitan ng mga PWDs, ng housing boards, urban development corporations nga, minsan sa mga road transport corporation na rin. Next. So, next naman natin is yung background information of concrete hollow blocks. Under nito is yung standard product size in the Philippines. This CHB sizes varies by different countries. So, may iba't iba tayong sizes sa bawat country. May sinusunod tayong standard size, tulad na lang sa Pilipinas, ang standard CHB size sa Pilipinas is may length na 40 cm, may height na 20 cm, and may depth na 10 cm or 4 inches, and 15 cm or 6 inches. So, basically, itong standard product size na to is sinusunod sa Pilipinas. And moreover, para maiwasan yung confusion sa panel and sa slab, CHBs is dapat hindi siya mag-exceed sa either sa length niya na 40 cm or di kaya sa 6 times ng width niya. Next is the product and material quality. Crushed, coarse, sand, and gravel is optimal for the manufacture of CHBs. So, itong CHBs, bago siya maging CHB, minamanufacture muna siya and galing siya sa raw material na cement, sand, and gravel. So, may tinatawag tayong low density block and high density block. Sa high density block, composed siya ng Portland cement and aggregates na usually yung raw materials nito is yung sand and fine gravels. While sa low density block naman is composed siya ng mga industrial waste such as the fly ash or bottom ash. At yung ginagamit nilang raw materials. So, ano nga ba yung fly ash? Fly ash is a residue generated in combustion and comprises the fine particles that rise with the flue gases. So, atong fly ash nito, simply, ito yung napoproduce during combustion of coal. So, tinatawag natin siyang fly ash. Pag sinabi namang ashes that does not rise, tinatawag naman natin siyang bottom ash. And the quality of CHBs varies significantly from one supplier to the next. Dahil nga, minamanufacture itong CHBs and galing siya sa mga raw materials. So, dadaan siya sa proseso bago maging CHB. Next. Next is yung suppliers. Sa suppliers, meron tayong sand and gravel na widely available sa Visayas region from local suppliers. Pero kung sakali mang yung structure na kinoconstruct mo ay nasa Maynila, hindi mo na kailangan dumayo pa sa Visayas region para bumili ng mga raw materials doon. So, kung meron namang supplier na mas malapit sa lugar na kung saan yung construction site mo is pwede ka na doon bumili. Hindi mo na kailangan dumayo pa kasi pwedeng mas mapagastos ka pa doon, lalo na sa transportation and sa mismong cost ng bibili mong raw materials. Cement, tulad ng di siya ng sand and gravel na kung may mas malapit na supplier na pwede mong bilhan, pwede ka na doon bumili. And CHBs mismo, it is recommended to procure products from suppliers with products certified by DTI and DPWH. So, atong CHB na gagamitin mo, hindi mo naman syempre, hindi ka bibili sa kung saan-saan lang. Dapat, alam mo na, yung gagamitin mo CHB is for the safety of people na gagamit sa structure na kinoconstruct mo. So, syempre, yung mga bibili mong raw materials or mismong CHB is approved ng DTI and DPWH para malaman mo safe na gamitin iyon. Next is yung environmental consideration. So, consider na dapat is more environmentally friendly alternatives yung yung lugar na pinagko-constructan mo and yung mga raw materials na bibilin mo. Next is yun. Next naman is yung advantages and disadvantages ng CHBs. Sa advantages, readily available product. So, dahil nga finished product na yung CHBs ng raw materials na cement, sand, and gravel, ready na siya for construction sites. Ready na siya for construction. Pwede mo na siyang gamitin as material for construction. And syempre, it has good thermal and sound resistance. These blocks lower the natural weight of masonry constructions and improve ini-improve niya yung physical properties ng isang wall such as ng noise nito and thermal insulation. So, good siya for thermal and nare-resist niya rin yung mga sounds dahil nga meron siyang mataas na physical properties sa noise and thermal insulation niya. And next is yung HIFI resistance. They provide, syempre, nagpo-provide sila ng mga lugar kung saan kinokonsume nila yung electrical conduit and water and soil pipe. And also, it can be reinforced to increase lateral resistance against earthquakes and typhoons. So, commonly, itong hollow concrete blocks masonry na to is durable siya sa compacted ng high pressure and vibration which gives ng substantial strength niya sa isang block. So, nag-i-increase yung compressive strength ng isang block dahil dito. And of course, the hollow blocks, yung mga voids nun or cores, can be filled ng steel bars para mas mapatibay pa yung strength niya and ma-achieve niya yung high seismic resistance para sa against earthquakes. And of course, meron siyang 20 plus years lifespan. Sunod naman is yung disadvantages. The cost of concrete hollow blocks is higher than the conventional bricks. The house built with hollow blocks without any interior reinforcements is likely to suffer damage during earthquakes. Tulad nga sinabi ko sa advantages, minsan pwede mo siyang gamitan ng steel bars para mas mapatibay ito. Kasi pag wala siyang interior reinforcement, yung mismong hollow block na to is pwede siyang mag-suffer and ng malaking damage during earthquake kasi mas weak yung hollow block if wala siyang seismic resistance such as steel bars or concrete sa isang CHB. So, next naman is yung video. So, magpapanood kami ng video wherein may kita dito yung advantages and disadvantages ng CHPs and kung anong importance kung bakit ba tayo gumagamit ng CHPs.
Concrete hollow blocks have been used in construction globally, including our neighboring countries. BTI introduces BTI building products with an aim to provide high quality and environmentally friendly building solutions. Concrete hollow blocks have several advantages over traditional bricks. A major advantage is that it is beneficial to the environment. When making traditional bricks, large areas of land are used, fuel resources are wasted, and air pollution emitted. Concrete hollow blocks are completely made using machines in a safe way which does not emit toxic fumes or pollute the surrounding environment. Concrete hollow blocks are made using local sand, crushed stone, sillet sand, and cement. Hydraulic pressure is applied on a vibration platform to create the solid hollow blocks. The hollow blocks are then left to dry under the sunlight for curing. The blocks undergo curing for several days. Concrete hollow blocks have several applications in construction such as internal partition walls, rooftop for heat protection, decorative architecture, and external walls. Concrete hollow blocks are advantageous for the following: environmentally friendly, stronger composition, greater earthquake resistance, heat and sound proof, no salinity, and reduced building weight.
So, good day everybody. Ang ire-report ko po ngayon is tungkol sa existing CHB and CHB wall standards in the Philippines. So, lahat po ng mababanggit dito is nakabase po sa National Building Code of the Philippines at saka sa National Structural Code of the Philippines. So, una, pag-usapan muna natin is yung load-bearing walls. So, load-bearing walls carries and distributes weight from the roof and the top floors down to the foundation. So, load-bearing walls, madalas natin siya makikita as exterior walls natin. So, since yung exterior walls nga natin yung nagke-carry ng weight, galing sa pinakataas ng building pababa hanggang doon sa foundation natin. So, usually, yung kapal na ginagamit natin for CHB ng isang load-bearing wall ay 6 inches. So, it must be type 1, class A or B unit, confirming with the ASTM C9070. So, minimum compressive strength ng isang CHB natin. So, 5.41 MPa or 800 PSI for individual CHB. So, dapat yung compressive strength na kayang i-hold ng isang CHB natin is 800 PSI. So, pwede siyang tumaas pa doon, pwede siyang bumaba. Pero yung minimum compressive strength na nire-require is 800 PSI. So, 6.89 MPa or 1,000 PSI based on the average gross area of Unit 5. So, non-load bearing walls. Placed inside the house and do not support any structural weight of the building. So, usually, yung non-load bearing walls natin, makikita natin siya as partition ng bahay, divider, o kaya ng bakod natin since hindi naman sila nagke-carry ng weight sa building natin. So, usually, kung mapapansin natin yung walls na mga non-load bearing walls, mas malinipis yung CHB na ginagamit sa kanya, which is may thickness lang na 4 inches. So, steel bars. To be laid in mortar, 1 part of Portland cement and 3 parts of sand. So, vertical and horizontal spacing as specified by structural engineers. So, yung steel bars natin, dinidesign siya ng structural engineers yung spacing at saka yung placement niya sa loob ng CHB natin. So, mortar and grout. So, mortar is considered tile adhesive. Grout is the filler applied between the tile spaces to fill in, seal the gaps. So, mortar and grout, ang pinagkaiba ng mortar sa grout is yung mortar is ginagamit natin siya as pandikit, while yung grout is ginagamit natin siya as filler. So, it must be type 1, 2, 3, or type 4 Portland cement conforming to ASTM C150 standard mix to the building code specifications. So, next na i-discuss ko is yung proportioning of concrete for manufacturing of concrete hollow blocks. So, sabi dito, it can be done in 2 different ways. So, proportion of CHB mix can be done in 2 different ways. It can be done by weight or by a volume. The most common method is by volume, using a bucket. So usually, hindi natin ginagamit, pwede namang gamitin siya as yung by weight or kikiluhin natin yung um, cement sa aggregates natin. Pero usually, ang ginagamit natin is by volume or yung per bucket nga kung makikita nyo sa mga construction na bucket yung ginagamit nila. So, for a mixture, for CHPs, mixed proportion is 1:7. Yun yung standard na mixed proportion natin ng CHB. So, 1 part ng cement tapos 7 parts ng aggregates. Usually, sand yung ginagamit. So, as per structural engineer specifications. So, nakadepende siya sa structural engineer kung paano proportion yung gagawin. Pwede kasi na 1:8 siya or 1:9. Depende sa kung gaano kakapal yung gusto nating maging CHB or gaano katibay yung gusto natin sa CHB. So, water. Clean water shall be used, shall not exceed 28 liters per 40 kilogram per bag of cement. Slump test as per ASTM C143 shall not exceed 10 centimeters unless specified by a structural engineer. So, dapat sa tubig, malinis na tubig yung ginagamit natin. Hindi tayo pwede gumamit ng tubig na may halong buhangin or tubig na parang maputik, gano'n. Kasi, magbabago yung kakalabasan ng CHB natin. Pwedeng hindi siya mag-form ng maayos or magkaroon ng ah, magkaroon ng um, yung mabilis siyang masira or madami siyang cracks kapag nahaluan siya ng ibang materials. So, common CHB mix. So, ito yung common na mix ng paggawa natin ng CHB. So, una is gumagamit tayo ng kalahating bucket ng water, tapos isang bucket ng cement, tapos 7 bucket ng sand. So, ito nga yung nakikita nyo natin is 1:7 yung proportion ng bucket ng cement sa bucket ng sand. So, common mortar mix, 1 bucket ng water, 1 bucket ng cement, tapos 3 bucket ng sand. So, nabanggit din kanina na yung sa mortar mix natin is dapat 1:3 yung proportion niya. Since makikita natin dito, 1 bucket ng cement, tapos 3 bucket ng sand. So, kung gagamit daw tayo ng mixer, use accurate timing and measuring devices to operate as per manufacturer's instruction. Kung gagamit tayo ng mixer, dapat sinusunod natin yung instruction ng manufacturer para makagawa tayo ng mas matibay at saka mas maayos na product, which is yung CHB nga natin. So, revolutions should be between 14 to 20 per minutes. So, kada isang minuto dapat umiikot yung mixer natin ng 14 to 20 times. So next is curing. After being removed from the mold, the CHB should be covered with a plastic sheet or tarpaulin and kept damp and shade for at least 7 days in order to effectively cure. This can be done by continually spraying them with water and or keeping them under water in tanks. A good curing process leads to less cracking, and stronger, harder, denser, and more durable concrete. So, sa process na 'to, makikita natin dun sa picture, yung unang picture natin is kaka-mold pa lang nung natin, ng CHB. Kakatanggal pa lang siya dun sa pinaka-mold. So, basa pa siya. So, sa susunod na picture is tinatakpan siya nung tarpaulin tsaka ng plastic sheet natin. So, yung sa pangatlong picture natin is ini-sprayan siya ng tubig. Para nga daw yung process natin is mag-produce siya ng less cracky, mas matibay, mas matigas, tapos denser, at saka mas durable na concrete hollow blocks. So, yun lang po yung report ko.
So ito na yung last part ng aming report, which is yung test for compressive strength ng concrete hollow blocks. So sa part na to is i-explain namin yung test method na ginagawa para ma-determine yung compressive strength ng isang CHB or kahit anong mga concrete masonry unit in general. So bakit nga ba natin kailangan pang alamin yung compressive strength ng isang CHB? So kanina nga may nabanggit si Jorens na minimum compressive strength requirement ng isang CHB. So with this test method na i-explain, ay makatetest natin kung yung gagamitin bang CHB ay up to code and if kung safe ba siya. So yung test method na i-explain nakabase siya sa ASTM C140/C140M-15 or yung standard test methods for sampling and testing of concrete masonry units and related units. Sa pagtest ng compressive strength is may dalawang machine na pwedeng gamitin, which is yung compression testing machine o yung universal testing machine na i-configure sa compression test. So based sa ASTM C140, nakalagay doon na dapat yung testing machine na gagamitin natin ay magko-conform sa mga standard na isiset sa ASTM C1716 or yung standard specification for compression testing machine requirements for concrete masonry units, related units, and prisms. So dun sa mismong test na, yung test specimens, ito yung mga CHB unit na itetest natin. Ang nakalagay sa C140 is dapat magtetest tayo ng 3 specimens in compression, pero sa mga na-search naming ibang source, ang sinasabi naman nila is dapat 8 specimens. Pero nakalagay din naman sa ASTM C140 na 3 specimens unless specified otherwise in the applicable annex. And yung mga specimens na itetest natin ay dapat full size units din. Pero kung yung mga units ay hindi pwedeng itest sa full size, halimbawa dahil sa configuration ng mismong units, hindi siya kasya dun sa mismong machine or yung mismong machine is hindi kayang itest yung full size na unit na yon, ay magre-refer yung magtetest sa Annex A1 ng C140. Next naman is test specimens pa rin. So dapat yung test specimens pagdating nila sa laboratory is hindi sila pwedeng i-stack at hindi sila dapat pwedeng pagdikit-dikitin na dikit na dikit. Dapat is at least separated sila by 0.5 inches or 13 millimeters on all sides. And yung mga specimen na yun ay dapat 28 days old na sila or na-cure na din halos at dapat matetest sila within 3 days pagdating dun sa laboratory. Next is yung tinatawag na capping. So yung bearing area of specimen ay ikakap siya with sulfur and granular material coatings or gypsum plaster capping. Yan yung makikita nyo sa picture. Dito ba yung yan, etong ayang parang CHB niya yan, tapos meron parang masilya sa taas. Yan yung capping na parang nilagyan ng gypsum coating. So ginagawa nila yan para ma-ensure nila na yung specimen ay meron siyang smooth, parallel, uniform bearing surface na perpendicular dun sa i-apply na axial load habang nag-undergo ng compressive strength test. Yung average thickness dapat nung cup na gagawin is dapat hindi siya lalagpas sa 3 millimeters at dapat papatuyin siya for at least 2 hours. Next is yung parang mismo ng pag-test nung compressive strength nung CHB. So sisimulan siya, bale susukatin muna yung CHB, kukunin yung physical attributes niya, yung length, yung width, yung thickness, and yung weight. So makikita nyo dyan sa picture yung malalaking dimensions kagaya nung yung width tsaka yung length, sinusukat gamit yung metro or ruler na calibrated syempre. And yung mga waves naman or yung mas maliliit na measurements, yung mga thickness na, sinusukat na gamit yung calipers and dapat calibrated din sila. So pagtapos sukatin ng mga physical attributes ng specimen, sisimulan na yung mismong compressive strength test. Isa-set up na siya dun sa compression machine kung saan dapat yung sample ay ipopwesto natin siya na nakagitna siya dun sa bearing plate ng top and bottom contact. Ayan, dito. Dapat nakagitna siya dyan sa dalawang steel blocks na yan. So ginagawa yan para yung centroid no CHB natin ay naka-coincide o nakapantay siya dun sa center of thrust nung blocks or nitong steel blocks, mga bearing plates na mag-UUP sa kanya, para yung axial load na i-apply is nakagitna nga dun sa centroid nung CHB. So at the same time, dapat susiguraduhin din natin na walang visible moisture or dampness dun sa CHB unit. Pag nasigurado mo na nakagitna siya, So, i-operate na yung machine. So, unti-unting bababa yung isang steel block papunta dun sa CHB, iniipit na siya para kumbaga ina-apply na yung axial load para makita na kung ano yung maximum compressive load na kayang dalhin nung CHB. Pag nag-crack na yung CHB, sign na yun na naabot niya na yung limit niya. So, ititigil na yung test. Tapos, titingnan na kung ano yung maximum compressive load na na-apply. Tapos, i-record siya in pounds or newtons, depende kung saang bansa, as Pmax. Yung nakuha doon, hindi pa siya yung mismong compressive strength. Kumbaga, yun pa lang yung maximum compressive load or axial load na na-apply sa CHB. So, based nga sa natutunan natin sa mechanics, para mahanap yung compressive strength, gagamitin natin yung formula ng stress, which is yung i-divide natin yung compressive load sa bearing area. Yung bearing area, yun yung top piece nga, yung surface area sa pinakataas nung CHB. Bale, merong dalawang klase kasi. Meron tayong tinatawag na gross area and meron din net area. Yung gross area, kumbaga yung CHB, tinitreat mo siya as isang solid block, yung taas niya, kumbaga wala yung butas-butas na yan. Kaya length times width lang, isang buo lang siya. Pagdating sa net area, ang kino-consider mo na lang is yung mismo talagang surface area niya. So may mga butas na hindi mo na i-minus mo na yan dun sa gross area na makukuha mo. Since may dalawang klase nga ng area, meron din dalawang klase ng compressive strength na binigay yung calculation dun sa C140. Meron tayo ng tinatawag na gross area compressive strength na in PSI or megapascals, which is bale yung maximum compressive load divided by sa gross cross-sectional area, and meron din yung net area compressive strength in PSI or megapascal din na parehas din lang pero ang kaibahan is maximum compressive load divided by net area. So hanggang dun lang po yung report namin. Salamat sa pakikinig.